Hey there, CJ's Math students. So we're going to have a class discussion on how do we figure out who is better statistically without bias, and it has to do with having equivalency between rational numbers, or having numbers mean the same thing, equal. So as we get right into it, some quick definitions. A percent is a number expressed as a fraction. It literally means per 100, right? So if you had a hundreds grid here, these are 10 by 10 boxes. If I wanted to fill out 20%, I'd fill out 20 of the boxes to get that 20%. Same thing with 50. See how half the picture is filled in? That's what 50% looks like. A decimal is a number that lies usually between integers, or aka whole numbers. It usually means base 10. Hence why all of our place values are going by tens, tenths, hundreds, thousands, 10,000s, ones, tens, hundreds, thousands, and so on and so forth. The decimal point allows a number to be in between two whole numbers. And finally, a fraction represents part of a whole. And in fractions, we have a whole bunch of different types of fractions. We have proper fractions, where we just have a numerator that is smaller than a denominator. We have improper fractions, where the numerator is larger than the denominator. And we have mixed numbers, where we have a whole number plus a proper fraction. Before we move on, it's important to figure out how to kind of convert between mixed numbers and improper fractions. So we're going to start off here. You'll notice I have a mixed number here because I have a whole number and a proper fraction. To change this to an improper fraction, because sometimes it's beneficial for us to work with improper fractions, I will multiply the whole number times the denominator and then add the numerator. So 3 times 5, and then just plus 1. That's how I get my 16, and then you just keep the denominator. So let's try here. 5 times 9, which is 45. We'll add that to 2, so I'll get 47 over 9. You try that one right there, 4 1/6. Now to do improper to mixed, that's where we have a numerator greater than our denominator. We're going to do some division. So we're going to keep the denominator on the outside of our divisor. We'll put the numerator on the inside and see how many times does it go in. That's our whole number. Whatever's left over, that's our new numerator. And again, same thing with the mixed numbers, we just keep the denominator. So let's do that. So for instance here, I'm going to say how many times does 4 go into 13? Well, 4 goes into 13 without going over 3 times. That gives me 12. There's 1 left over, so this is my new whole number, 3. 1 left over is my new numerator, 1, and I keep my denominator of 4. Right? You try 25 over 7. So, as we flip over to the back side, it's important that we're just going to focus on 2 conversions today. Decimals to percents, and percents to decimals. So this is very, very simple. To convert a decimal to percent, now we're going to move the decimal point 2 places to the right, aka multiply by 100. So 0.7 is the same thing as 0.70 or 70%. You'll notice if you move 2 places and there's an empty space, a 0 gets added. So to recap, we start at the decimal, swoop 2 times to the right. It's the same thing as multiplying the decimal by 100. So for instance, 0.5, to make that into a percent, I swoop once, twice, and any empty space gets filled with a 0, so I have 50%. 0.5 and 50% are the same thing. Notice the difference between 0.5 and 0.05. I'll swoop twice, once, twice. It ends up right there. 0.05 is the same thing as 5%. Right? And then percent to decimal, we're going to go ahead and start at the end of the percent. Again, swoop 2 times, but this time move to the left. This is the same thing as dividing a decimal by 100. There is a special case here. If there is a decimal point in the percentage, you start at the decimal and still move 2 places to the left. So for instance, if I have 10%, I'm going to swoop once, twice left, and that is the same thing as 0.10 or 0.1. If I have 257%, watch what happens here. I'm going to swoop once, twice. I end up in between the 2 and the 5, so that's the same thing as 2.57 as a decimal. I have 2 wholes and 0.57 extra left over. We are now going to do some practice together. Pay attention for our instructions here.